All right, let's dive into some cutting-edge robotics research.
Sounds exciting.
You mentioned you're fascinated by how robots are starting to move around in real time.
Yeah, it's amazing how they're not just stuck following pre-programmed paths anymore.
Right. And this paper we're looking at today, Motion Policy Networks, from 2022, is going to blow your mind.
I've heard good things about it.
It really pushes the limits of what we thought robots could do.
Yeah.
Well, for starters, it introduces these things called motion policy networks.
Catchy name.
Right? MpNets, it sounds like something straight out of sci-fi.
Yeah, it does.
But it's not just a cool name. The results they got from real-world robot tests are insane.
Oh, really?
The robots using these MNets were 46% more successful at reaching their destinations without bumping into anything.
46%? That's a huge improvement.
It is. And the paper makes a good point. That kind of performance jump isn't just a small step forward.
Right.
It's like the difference between a robot being trapped in a lab and actually being able to function out in the real world.
Like in our homes or workplaces.
Exactly. So how do they do it? Well, the paper says these MNets are a type of end-to-end neural network.
Okay.
But I'll be honest, I'm not an AI expert.
No worries.
What does that actually mean in plain English? Like, how is it?
You scan a room with it, and you get a 3D map made up of millions of these points, each with its location in space.
Ah, so it's like giving the robot 3D scanner vision.
Exactly. It's not just seeing flat images anymore, it's understanding depth and the shape of its surroundings.
So the robot is navigating this invisible fabric of smooth and rough areas.
That's a great way to put it, and because it's learned from millions of simulations, it can do this incredibly fast, in real time.
Even as things are changing around it.
Exactly, which is what allows it to weave through obstacles, make those sharp turns, and just move with this fluidity we've never seen before.
Okay, now I understand why that 46% improvement is such a big deal. It's not just about avoiding the things it sees.
It's about predicting what might happen.
Right. That's incredible.
It's a pretty radical shift in how we think about robot navigation.
And the coolest part, they didn't just test this in simulations.
They put it on real robots, too.
Wait, so these robots were actually moving around in the real world?
Out there dodging obstacles.
With this geometric fabric guiding them. That's amazing. But how did they even train the network on such a massive scale?
Well, it does sound like something out of a sci-fi movie, right?
Did they hire, like, a team of video game designers to create all those simulated environments? By hand?
It would be a dream job for some video game designer.
Right.
But luckily, no handcrafting was needed.
So how did they do it?
They used this technique called procedural generation.
Procedural generation. Now you're speaking my language.
You familiar with it?
It's how they make those huge open-world video games, right?
Yeah.
Where the landscapes just seem to go on forever.
Exactly. It's all about using algorithms to create stuff automatically, like environments, objects, you name it.
So for the robots, they basically built a training ground that never ends.
And it's always throwing new challenges at them.
Smart. But even with procedural generation, wouldn't it take forever to process all that data?
You and me both. My gaming PC can barely handle one open world.
Exactly.
That's where the magic of cloud computing comes in.
Ah, of course, the cloud.
It's like having a supercomputer at your fingertips.
So they harnessed all that power to speed up the training.
Yeah, they basically used huge data centers to crunch through all those simulations.
The cloud, the unsung hero of so much AI research. Okay, so we've got robots learning to navigate in real time thanks to this crazy combo of neural networks, point cloud data, geometric fabrics, procedural generation, and cloud computing.
It's a lot to take in.
My head is spinning. But beyond all the tech, what does this mean for the real world? What problems can we actually solve with these super smart robots?
Well, think about self-driving cars.
Oh yeah, they've been promising us those for years.
And we're still waiting.
Right.
But imagine if they could actually live up to the hype.
Okay, I'm imagining.
Not just inching along on highways.
Right, that's not real self-driving.
We're talking navigating busy city streets.
Oh, wow.
Crowded intersections, even those narrow European streets that make me nervous just thinking about them.
Yeah, no more parallel parking struggles I'm in.
Exactly. And it's not just about getting from A to B.
What else?
Think about delivery robots.
Okay.
Bringing you your online orders, your takeout.
Without ever having to see another human.
Exactly. Or search and rescue robots. The ones that can go through rubble to find survivors after a disaster.
Okay, now you're talking. That's the kind of robot future I want to live in.
Helping people, not replacing them.
Exactly. That's always the worry, right?
It's a valid concern.
But for now, let's focus on the good stuff.
The positive impact?
Yeah. Like robots in healthcare, helping out in hospitals,
delivering meds, moving equipment.
even assisting surgeons with complex procedures.
Precisely. Imagine the level of precision they could bring.
Wow, now that's mind-blowing.
It is.
But let's be real, we're still in the early days, right? This is all research. What are the challenges? What needs to happen before we see robots navigating our world seamlessly?
Well, one big one is robustness.
Okay.
These networks are trained on tons of data, but the real world is full of surprises.
Right.
Things simulations can't fully predict.
Like a sudden downpour turning the sidewalk into a slip and slide for our robot friends.
Exactly. Or a flock of pigeons having a party in the middle of the road.
Ugh, pigeons. The robot's worst nightmare.
Maybe. But the point is, the real world is messy, unpredictable.
Yeah, and robots need to be able to deal with that.
Without freaking out.
Or worse, causing harm.
That's the big one. Safety is key.
Right now, it's cool that robots can dance around obstacles.
Yeah.
But what happens when it's rush hour?
And the sidewalks are packed.
With kids, pets, people who aren't paying attention.
It's a real concern.
How do we guarantee these robots will make the safe choice? Every time.
Well, that's why researchers are working on new algorithms, new safety protocols.
Okay.
To ensure these robots operate responsibly.
In the real world?
Exactly. And one promising approach is to incorporate human feedback.
Like training a puppy not to chew on the furniture. But for robots.
Exactly. By giving them feedback.
We can teach them what's right and wrong.
To prioritize safety, make ethical choices.
Even when things get complicated.
Exactly.
Makes sense. But even with all the safety measures.
There's still the question of public perception.
Right. Are people going to be comfortable sharing their sidewalks with robots?
That's a big one.
Some people are already scared of self-driving cars.
It's understandable.
And those are just cars.
Yeah.
Now we're talking about robots that can move freely.
It's a valid concern.
So how do we address that?
I think public education is key.
Okay.
Open dialogue, demystifying these technologies.
And showing people the benefits.
Absolutely. We need to move beyond the sci-fi stereotypes.
Robots as either our helpers or our overlords.
Exactly. They're tools.
And like any tool, it depends on how they're used.
And who's using them?
We need to ensure they're used responsibly.
Ethically.
I like that, well said. So we've talked about the challenges, but let's get back to those real-world applications.
Okay.
What are you most excited about? Where do you think MpNets could have the biggest impact in the near future?
That's a tough one. There are so many possibilities.
I know, it's exciting.
If I had to pick one, I think it would be logistics and delivery.
Okay, interesting.
Imagine a world where packages are delivered by swarms of robots.
Instead of those giant delivery trucks.
Exactly.
That would be amazing.
Navigating our cities with efficiency and precision.
No more delivery trucks double parked on my street.
Exactly.
And it would probably be better for the environment, too.
Faster, cheaper, and more sustainable.
I can see that. And maybe we'd even get some of our roads back.
Maybe one day.
For us humans.
For now, we're still in the early stages, lots more research to be done.
So what are the next big steps? What are scientists focusing on right now?
One exciting area is pushing the limits of what these robots can perceive
Okay.
and understand.
So not just seeing the world, but understanding it.
Exactly. Right now, they mostly rely on point cloud data.
Yeah, the 3D maps we talked about.
But what if they could also grasp semantic information?
Semantic information. You mean like knowing that a chair is a chair?
Not just a bunch of points in space.
Right, yeah.
Exactly. If robots could understand the meaning of things
That would be a game changer.
and their relationships to each other,
Like not just avoiding a closed door, but understanding that they need to find another way around.
or even figuring out how to open the door.
Wait, robots learning to open doors.
Yeah, think about it.
That's both cool and kind of terrifying.
I know, right? Sounds like science fiction.
But it would make them so much more useful.
In our homes, in our workplaces.
Okay, I'm officially both excited and scared for the future.
I get it.
But before we spiral into a robot apocalypse fantasy,
Right, let's stay grounded.
let's go back to the paper.
Okay.
They said something about these geometric fabrics being able to adapt to different robots.
Yeah, that's another cool aspect.
What does that even mean?
So the geometric fabric isn't just a fixed map. It's more like a dynamic representation
It can change.
based on the robot's abilities, the task it's doing.
So a robot with wheels would have a different fabric than a robot with legs. And a robot designed for delicate tasks, like handling fragile objects, would have a different fabric than one for heavy lifting.
Precisely. It's like giving each robot a custom navigation system.
perfectly suited to its body and its job.
Yeah.
That's amazing. But I have to admit, this whole concept of geometric fabrics is still a bit abstract for me.
It is a bit tricky to visualize.
Yeah, any chance you could break it down for me?
Sure. Think of it this way. Imagine you're going for a hike in the mountains.
Okay, I'm picturing it.
You wouldn't just walk in a straight line, right?
Yeah, no, you'd follow the trails.
You'd look for the easiest paths, the ones with gentle slopes.
Avoid the cliffs and the, what are they called, scree fields?
Yeah, something like that. You want to avoid the rough terrain.
Right.
Well, the geometric fabric is like that topographic map for the robot.
Okay.
It shows all the possible paths.
And the smooth areas are the easy paths.
Exactly. Smooth
And
movement.
the rough areas, the obstacle.
Or difficult terrain.
So that a MpNet is like a super smart hiker,
I like that analogy.
always looking for the easiest way to get where it needs to go.
And just like a hiker adjusts their path based on what they see,
Right.
the fabric can adapt.
To different robots, different tasks.
A wheeled robot might stick to smooth paths.
While a legged robot could handle something rougher.
Exactly.
It's like the robot is wearing custom hiking boots, perfectly suited to the environment.
That's a great way to think about it.
So we've talked about all the cool things these MpNets can do.
Yeah, it's pretty impressive stuff.
But what other things they can't do? Are there limitations to this technology?
Of course, nothing's perfect.
Right.
One thing is, they still rely a lot on simulations for training.
Okay.
And as good as our simulations are getting,
they're not the real world.
exactly, they can't capture every detail, every possibility.
So what happens when a robot encounters a situation that wasn't in the simulation?
That's the challenge, right?
It's like, what if our hiker suddenly encounters a river and they never learn to swim?
Good analogy.
So the robot might freeze up.
Or do something unexpected.
Not good.
So that's why a lot of research is focused on making these networks more adaptable,
Huh?
more robust, able to handle those surprises.
Like teaching our hiker to build a raft.
Exactly. Give them the tools to handle the unexpected.
Okay, that makes sense. And what about the ethical side of things? We touched on it before,
Yeah, it's a big one.
but it seems like there are a lot of potential dilemmas when you have robots navigating our world.
Especially with this level of autonomy.
Like, who's responsible if a robot makes a mistake?
That's a tough one.
How do we make sure these robots are only used for good?
These are the questions we need to be asking.
There aren't easy answers.
No, but they're important questions.
It feels like we're entering a whole new era of robotics,
It really does.
where the ethical questions are just as important as the tech itself.
Maybe even more so.
It's not just about building cool robots anymore,
It's about figuring out how they fit into our world.
and how we want that world to look. Well, I think this deep dive has been a great step in that direction.
I agree.
We've gone from the basics of motion policy networks to the mind-blowing potential of geometric fabrics.
And we even touched on some of the ethical challenges ahead.
It's been quite a journey, and I hope our listeners are feeling just as excited about the future of robotics as I am.
I hope so too.
But before we wrap up, I want to leave our listeners with one final thought.
Okay, shoot.
We've been talking about robots navigating physical spaces.
Yeah.
But what about using MpNets to navigate more abstract spaces,
Interesting.
like the complex world of data?
You mean instead of navigating streets and buildings?
Robots navigating information.
That's a fascinating idea.
Could they help us make sense of all the data overload we're facing?
It's like giving robots the ability to think.
To learn, not just react.
That's both exciting and a little daunting.
I know, right? It's a lot to ponder.
It is.
Well, on that note of existential wonder, I think it's time to wrap up this deep dive.
Time flies when you're having fun with robots.
Uh-huh. Yeah, it does. A huge thank you to our expert for sharing their insights and for taking us on this incredible journey into the world of motion policy networks.
It's been my pleasure. I always enjoy talking about this stuff.
And to our listeners, thank you for joining us. Keep exploring, keep questioning, and keep imagining the possibilities.
The future is full of surprises.
And who knows, maybe one day, those surprises will include robots that can not only navigate our world, but help us understand it in ways we never thought possible.
I can't wait to see what the future holds.
Me too. Thanks again for listening.